Hey guys, welcome back to another interesting topic. Today's topic is about clock skew. So what's a clock skew? So clock skew is nothing but the difference between the arrival time of the clock at different devices. So what does the difference between the arrival time of clock mean? So I'm going to take an example over here. As you can see this example, we have two flops connected with the combinational logic, and they are getting the clock from same clock domain. So this clock is reaching the clock 1 and this clock is reaching the clock 2, but there is a certain delay, that is net delay. You can say that the distance between clock and clock 1 is less and the distance between clock and clock 2 is more compared to clock 1. So the arrival time of this clock at clock 1 is faster than arrival time of clock at clock 2. Okay, so clock is gonna arrive faster at clock 1 than clock 2. As a result, we will have a certain delay over here. This is caused due to the net delay of this wire, or you can say buffers. Okay, now let's look at the timing diagram. Here the timing diagram shows like this. I'm considering that there is no delay between clock and clock 1, that the arrival time is 0 for clock 1. As a result, we will get the clock at 0th time, but there is certain amount of delay in the net delay. Let us consider this is having a 5 seconds of net delay. So clock will reach after 5 seconds at clock 2. As a result, we will get a small difference between the arrival time. So let's say this is considered as delta. This delta is the clock skew. Okay, this delta is the clock skew, which is called as a clock skew. That's the difference between the arrival time. So clock 2 is obtained at 5 and clock 1 is obtained at 0. So this is the arrival time difference. I hope you have understood what is meant by clock skew. The clock skew are of two different types: positive clock skew and negative clock skew. Now I'm going to talk about positive clock skew. So what does a positive clock skew mean? So when both the data and the clock are traveling in the same direction, that is when both the input and the clock are traveling in the same direction, then it's a positive clock skew. Whatever the skew comes, that's a positive skew. So now I'm going to take this example where we have three flops R1, R2 and R3 connected with some combinational logic in between, and the clock delays are also considered. For here the clock needs to travel from clock 1 to clock 2 to clock 3, so there is a certain delay over here. Now I'm going to show you the timing diagrams, how it will look and how the timing delay will affect the clocks. So here is the timing diagram. As you can see in the picture, that we are considering a clock with a time period of T clock. Okay, this clock is getting to all the three clocks over here: clock 1, clock 2 and clock 3. But in ideal condition, all the clocks should be similar, but here we have the delay in between that is causing the skew. Okay, that is causing the arrival time difference. Okay, now since I'm considering that there is no delay for the clock to arrive at clock 1, so clock and clock 1 will be similar. Okay, clock and clock 1 are similar. Now the clock 2 has certain delay. As you can see, there is a certain delay over here, that is delta amount. So clock will appear at clock 2 after delta amount of time. So this is the delta. After delta amount of time, we will get the clock at clock 2. So but to reach clock 3, there is one more delay, that is delta 1. So we will get clock after delta plus delta 1. Okay, delta plus delta 1. So this is the amount of time after which we will get the clock at clock 3. I hope you have understood. Due to the positive skew, we are shifting the clock in this manner. As a result, we are getting, suppose this is our launch edge, our capture edge is over here. So time period is increasing between the launch edge and the capture edge. I will discuss about it in detail, don't worry about launch edge and capture edge. So now let's go to the negative skew. So as you might have guessed, negative means data and clock are in opposite directions. As you can see from this example, that input data is coming from this side, from left to right, and the clock is coming from right to left. As a reason, we will have a different timing diagram compared to the positive skew. Let's look at the timing diagram. Here we have the clock. This is the clock, this is my clock with the time period of t clock. This is the time period of t clock. Okay, now this t clock time period is nothing to do now. We are getting no delay for clock and clock 3. As a result, the clock and clock 3 are similar over here. You can see that clock and clock 3 are similar, but we are having a delta amount of delay for clock and clock 2. As a result, we will get clock 2 after delta amount of time. So we are getting clock 2 after delta amount of time, and clock 1 we will get after delta plus delta 1 amount of time. So here you can see that clock 1 is coming so late after delta plus delta amount of time. So here, if this is our launch edge, then capture edge is over here. Now we are reducing the time between the launch edge and the capture edge. It has been reduced compared to the positive skew. Okay, now I'm going to discuss how it's going to affect our timing. So the skew, how is going to affect our timing and advantages and disadvantages. So before going to that, I want to discuss about setup time and hold time. So what is the setup time? So let's consider this is our capture edge. So before this edge, the data, input data, whichever we are giving, that might be 1 or 0, that must be stable before this time, the amount of time between the capture edge and the certain amount of time. So in this time, our data should not change, and before this time, our data should become stable. Okay, that's our point, and that is called as a setup time. After we are getting the data at the capture edge, after the capture edge, the data needs to be stable for certain amount of time, that is hold time. I hope you know setup time and hold time. So now I'm going to discuss a condition where there is no clock skew. After that, I'm going to discuss where there is a clock skew. Guys, this example doesn't have clock skew. I'm going to illustrate an example where there is no clock skew and then take the clock skew in consideration for our thing. So now here there is no clock skew. As you can see over here, clock and clock 2 are reaching at same time. There is no difference between clock and clock 2. So let's consider how this works. So input is given as 1, so this edge will detect it as 1 and give it to the Q1 after TC-Q delay, TC to Q delay. So it will give from TC to Q delay, and we will get 1 at this. After certain time, we will get 1 at Q1. So at this edge, it is reading 0 for Q. So it will be 0 from here to next edge. It will be 0 from this edge to this edge. It is not reading 1 at this edge. So this is our capture edge. Whatever is seen over here is captured after a 1 clock delay. Okay, one time period. So if you launch over here, it will be seen here. If something is launched, suppose 0 is launched over here, so it will be seen after one more clock period. So 0 will appear over here. I hope you are getting this. This is a crucial point. Okay, so this is the TCQ from where we are getting, because we have certain delay from clock pin to Q pin, and after that we have some combinational delay. So this, from this one to this one, this is called as a combinational delay, T combo. So this will be useful for in our equation. So our equations get something like this. So TCQ is our T clock to Q pin plus T combo is the actual time, is the arrival time, how much time which we are going to get. So this is the arrival time. So actually we need that before the setup time, our data need to be arrived. So that is T clock is the clock period minus T setup. So this is our required time. Okay, this is our required time. I'm not considering clock skew over here, don't forget that again. So this is arrival time and this is required time. So if arrival time is greater than required time, then it is a violation. If arrival time is less than or equals to the required time, then it's a good condition. There is no violation for setup. So these are the setup conditions. And for hold, we need to know that arrival time should be greater than hold condition. The hold time, should be greater than hold time. If this happens, then it's perfectly fine for the hold. Now I'm going to discuss where there's a clock skew in between. There is no clock skew over here. I'm going to discuss a condition where a clock skew is there. So I'm taking the same circuitry but with some clock skew. So as you can see over here, clock and clock 1 are not appearing at same time. There is a certain delay between here, this clock and this clock edge and this clock edge. Let's say it's delta. Okay, this much amount of delay is there, that is delta. Now let's look how this functionality functions. So first, the clock is there. We are giving the input as a D. So D is being given as input. So we will get Q1 after a certain period of delay, that is TC to Q. There is a small delay called as TCQ. Okay, we are getting 1 after a certain period of time. So now this Q1 is being given to D2. But Q1 will be, so we need to cross all this combo. As a result, we will get a T combo delay. So T combo is shown over here. See this T combo delay? So we will get D2 after T combo delay. Okay, from here to here we have T combo delay. So first neglect this clock. After that you can see that. So from here to here we have a T combo delay. I will show you one more clearly. I'm drawing a dotted line. So this is a T combo delay. T combo. So after T combo delay, we will get our D2 as our input. Now when the pause edge comes at the clock, whenever the pause edge comes at the clock, then we will detect the D2. So whenever the pause edge comes at the clock 2, then we will detect D2. So when D2 is detected, after a certain period of time, TCQ, again TCQ is there, from C to Q2, there's certain amount of delay for it. So you are gonna get TCQ again, and then you're gonna get our output TQ2. I hope you understood it. So I'll discuss it once more time for your clear understanding. So first we are gonna give input. So D1 is being given at the flop 1. So but after TCQ amount of time we will get at Q1. So after TCQ amount of time we will get at Q1. So after T combo delay we have to cross through this all combo. Don't forget that we have to cross through this all combo. So that combo delay I'm considering at T combo. After T combo delay we are going to get D2. So here it's not going to detect because it's a edge triggering. So it will detect at the positive edge. So I'm taking it the positive edge. It will detect at positive edge. So it has detected that D2 has changed. So now it will change Q2, but after TCQ delay. I hope you have understood now. And we have a small amount of delta also. So now how this Q is affecting our setup condition and hold condition. I'm going to take 2 examples and clear your all doubts in setup and hold time. Hey guys, now I'm considering 2 cases, A and B. So in A condition, we are getting clock after, for clock 2 we are getting after a delta of delay, and here we are getting clock 1 after delta of delay, and I'm considering same circuit. Okay, don't forget that I'm considering 2 flops with some combinational delay in between. Okay, so here our time period in case A, I'm gonna first go with case A and then go with case B. So in case A, what's happening is that our time period is being increased. So whatever data we are going to launch over here is going to capture at this edge for the next flop. So whatever we are going to launch over here will capture at this flop. So we are going to get extra delta. So our time period now will become from t clock to plus delta because we have an extra clock skew. So with increase of the clock skew, what's happening is that our setup analysis is having more amount of time so that our data can settle. So this is an advantage for setup. Okay, whenever the clock skew is increasing, we are having an advantage in setup analysis because the input is getting stable. So setup will have no problem with the increase in the clock time, in the skew time. Okay, when the skew increases in this condition, in this type of condition, for example, this is a positive skew. So if the skew increases, it will have more time for settling down the input because we need to settle down the input before the clock edge. So if this is a pause edge, so it needs to be settled before this. Now because of the delta amount of time, delta amount of delay, we are having more time to settle down before the setup time. I hope you understood. Now let's go for case B. So now I'm considering case B. Here clock 2 is arriving faster than clock 1. So this is a negative skew. As you can say, this is our launch edge. So this is our launch edge and this is our capture edge. So this is a negative skew. So launch is appearing later compared to the capture. So this is a negative skew. What happens to the time period? So time period will be reduced from this edge to this edge. So how much time period has been reduced is t clock minus delta. So as a result, we are having a problem over here. We are having a less amount of time for the input to settle. So the input must settle before the clock edge, before the certain amount of time, before the setup time, it must be settling down. But here we are having a less amount of time. As a result, the setup analysis is happening. This setup analysis will have a problem when the negative skew increases because we will have a less amount of time for the input data to settle down. So now I'm gonna deal both examples again with the hold analysis. So I'm going to write the equation for setup analysis. Okay, so this is our setup equation. So this is our setup equation. TCQ is the clock to Q pin delay and T combo is the between combo delay. So this is our arrival time. So this is arrival time should be less than the required time. What is the required time? T clock minus T setup plus TCQ. So that whenever the arrival time is having a more amount of time, at that time if we are having more skew, that means it's benefited for setup time. If arrival time is more and the skew is having a negative, negative skew is there, then that might be a problem because it might fall under it might fall under our case where metastability might occur. So as a result, you understood that the two conditions, in case A it's better for setup and case B it's not better for setup. So now I'm going to discuss it for the hold. So I'm considering the same cases for again. As you can see over here, we have two clocks, clock 1 and clock 2 in case A and case B. Here we have delta amount of delay. Here clock 1 is coming after delta amount of delay after clock 2. So I'm going to discuss case A now. So let's go with the case A. So what's happening here is that delta is increasing. So we are having an extra time after this one. So this, let's say this is the whole time after the capture edge. Certain amount of time we need to be stable. So let's consider this as the whole edge from this point to this point. Okay. So this is gonna create a problem because we are gonna stay for more extra time of delay. So we are gonna stay hold plus delta amount of time. Before it was hold, we need to be stable, but it is hold plus delta amount of time. So this is gonna create a problem for hold. This is a problem. Okay, this A condition, as the skew increases, it will for sure result a problem in hold time. Now let's go for case B. In case B, what's happening is that the clock 1 to clock 2, so this is the capture edge and this is the launch edge. Okay, so this is the capture edge. Here the delta is being removed from the hold time minus delta. Okay, the skew is removed. As a result, if the skew is removed, we need not be stable for less than delta amount of time. So if the input must be stable for whole amount of time, now it need to be stable for whole minus delta amount of time. As a result, we are going to reduce the time period of whole time period is reduced, so this will not create no problem. So this is a good condition. So a negative skew, this is a negative skew, so when the negative skew is there, whole time will be good, and when the positive skew is there, there's a problem with the whole time. And it's the reverse condition in setup. I have discussed about it. So now let's go over the whole equation. So this is the whole equation. Okay, this is the whole equation, and this is our arrival time, and this is our required time. So this must be greater than this one. So dcq plus ta must be greater than t whole plus t skew, because our input must be stable in the whole window. Okay, our input should be stable in the whole window. If this is the capturing edge, in this window it must be stable. Okay, as a result, we are getting, if the negative skew is there, we are reducing this window. If positive skew is there, we are increasing this window. So in case A, there is problem, and in case B, there is less of problem with the whole. I hope you understood now the whole equation where it's causing the trouble. Now let's discuss about advantages and disadvantage of the skew. So I'm going to discuss about the advantages. What is the advantage is that if the input, whichever is coming, whatever the input we are giving is reaching at this time, suppose let's say it is reaching at this time, if no skew was there, this positive would be over here, and there the transition is not allowed. So if there will be a transition over here, and it would lead to metastability. Okay, it might lead to metastability. If there was no skew over here, our clock should be over here. As a result, it will be leading to metastability. So due to the skew, now we have moved our edge a little bit further. As a result, the setup time violation is avoided, and I hope, and the metastability is also avoided. So this is called as useful skew. Okay, this is called as a useful skew. Okay, sometimes skew might be useful because you need to have certain amount of delay to hold to neglect the violations of this kind. Okay, now let's go with the disadvantages. So there are so many disadvantages with the skew. So coming to the disadvantages, when we give the data, so if the data is changing over this period, so suppose our data is being changed over this period, let's say our input, whatever we have given, is changing over this period, and because of the skew, it is changing in the setup time or the whole time, and it is causing the output to be metastable. Okay, it is causing the output to be metastable. As a result, we are going to get lots of amount of problem in future because this output is not decided. I hope you have understood. This video might be long, but I hope this is worth it to watch. And please, before you leave, I wanted to say one thing. Please do it, man. It will be a lot helpful for me to do more videos for you. And please comment down below if you have any doubts. Thanks for watching, and please do subscribe. Click it on it now before I write. Click now for subscription. And thanks for watching once again. Thank you so much.